So in this question, I am told that here is a right-angled triangle, and I'm asked to work out the value of x, which is the length of one of the sides. Now, if you're given a right-angled triangle, you know there's two things that you can use. The first thing is Pythagoras, and the second would be trigonometry. Now, Pythagoras is when we have two sides that have been given and we're trying to work out a third final side of a right angle triangle. So in this case, I know I'm going to use Pythagoras. I don't need to involve trigonometry. So Pythagoras' theorem states that a squared plus b squared equals c squared, where a and b are just the length of the two smaller sides or shorter sides, and a c is the length of the hypotenuse, where the hypotenuse is the side opposite the right angle. Okay, so what I do is I just substitute my values into this formula. Now I've been given the length of the hypotenuse, so therefore I rearrange this equation to be c squared take away a squared equals b squared. And the reason I do that is because Pythagoras was based on essentially if we drew a square around each of the sides. So over here you've got a square of length 4 centimeters, which would be 16 centimeters squared. Here you have a square of length 8.5 centimeters, so the area of that would be 8.5 times 8.5, which is 72.25. And here you have a square with a length x, so you know that area is going to be x squared. Now, however you do this, for any right angle triangle, the area of the two smaller sides, the squares formed by the two smaller sides, will sum to make the area of the largest side, the square formed by the hypotenuse. So I know that 72.25 take away 16 must give me the area of the square over here, x squared. So I can just type that into my calculator and it leaves me with 56.25 equals x squared. So I know the area of this square here is 56.25. The final part is I know x squared is equivalent to 56.25, so I square root both sides to get the value of x by itself. So the square root of my answer is 7.5. And that is how I would work this out. So if Pythagoras is something that you've forgotten about, then be sure to check out the full length video. This is just a quick whistle stop tour. So the last part of question 1 is asking you to factorize something fully. So what you can do if this question is something that you find a little bit tricky is think about what the algebra is doing and go from there. So the first thing I want to do is split up my terms into finding out what the algebra is actually doing. So that's 15 times by x times by x times by x plus 3 times by x times by x times by y. All I'm doing is I'm breaking up into its purest form. If you wanted to be even more accurate, you would think, okay, so I've split up the algebra into its pure form. Now, can I split up the numbers into their pure form too? So into their prime factors. So I've got 3 times 5 makes 15, and 3 is just itself. You don't have to split it into 3 times 1 because it's a prime number. So you're then left with 3 times 5 times x, and 3 times x times y. Now, what you want to do when you factorize is you want to look at the two terms and pull out the highest common factor of both of them. So anything they have in common, you pull out and you put that outside of the bracket, and anything that's left goes inside the brackets. So I know I'm going to put things in brackets, and I'm going to pull out the largest thing they have in common. So they've got 3 in common, so I can put that outside the bracket. Then they've got x in common, so I can put that outside the bracket. And there's another x in common, so I can put that outside the bracket as well. Then all I'm left with for the first term is 5 times x plus y. Now, what I want to do is simplify that. So that would be 3x squared brackets 5x plus y. So I've pulled out the largest common factor from both of the terms. and that's how I'd do this question. Obviously, I've broken it down into lots of detail. You can also just do it really quickly just by knowing that x squared is the largest factor, but this is how you do it if you struggle with this question. So here we've got a best value problem. I'm told that Jenny is going to buy 20 litres of paint, and here's some information about the cost of paint from 2 different shops and which shop should she essentially buy it from. She wants to buy 20 litres of paint as cheaply as possible, so we need to figure out how much it's going to cost in both of the shops. So for prime paint, I know that 2 litres cost £21, and I know that she wants how much? 20 litres. So if you just set up a little equation like this, you can use the unit method. So you just think to yourself, what do I multiply 2 by to get to 20? I multiply it by 10, so I do exactly the same thing on this side. Therefore, 20 litres is going to cost £210. There's no special offers, so that's just the price she pays for there. Then we can look at paint for less. So I know that a 5 litre pot, the normal price is £65, and I know that there's currently a sale which is 15% off the normal price. So I know that I can get 5 litres, and you can either work out the 15% first, so do 0.85 times 65 and then multiply it by 4, but I'm just going to work out the total cost and then subtract 15%. So I know 5 litres is normally £65, and I want to figure out how much 20 litres is. So what do I do? Well, to get from 5 to 20, I multiply by 4, so I have to do the same over here. And 65 times by 4 gives me 260. So the normal cost over here would have been £260, but there's 15% off the normal price. And remember, as a multiplier, if you have 100% and you take 15%, you're left with 85%. And what does percent mean? It means divided by 100. So 85% as a multiplier is 0.85. So to work out like 15% off, just a quick way with the multiplier, we'd just do 260 times by 0.85, which is, times 0.85 is £221. So I would say she should buy from prime paint as it is £11 cheaper. Always, when you've got a question like this, you need to maybe even circle your answers just to show it, just to make it clear to the examiner where they are. £210 versus £221. So in this question, I've been given some unknowns, and whenever I have an unknown, I want to use algebra. So I'm told that Chiara is 7 years older than Jay. So Jay is the person who I know nothing about. I can say that Jay is my original unknown. So I'm just going to say Jay is X years old. Don't know how old he is, but however old he is, we're going to say it's X. I can then form an expression about how old Chiara must be, because if Jay is X years old, Chiara is going to be whatever Jay is plus 7, because she's 7 years older than him. I'm then told that Martha is twice as old as Chiara. So whatever Chiara is, Martha is double that. So I can put that in a bracket because it's double whatever Chiara is. And I could expand that if I wanted to. So 2 times x would give me 2x. 2 times 7 gives me 14. Okay. I'm then told that the sum of their ages is 77. And sum just means the end result after you've used addition. So I can form my expression. I know that Jay's age is x. If I add Chiara's age to that, that's x plus 7. And then I add Martha's age, that's 2x plus 14. I know that all of these ages, these expressions must sum to make 77. So I've got an expression, and now what I want to do is just simplify it. So collect all of your like terms. I've got x plus 2x, which is going to give me 4x. And then I've got 7 plus 14, which is 21. So 4x plus 21 must equal 77. If I write that up here, 4x plus 21 equals 77. What would I then do? I need to solve this equation to find out what the value of x is. So I can start by subtracting 21 from both sides, and I'm left with 4x equals 77 take away 21 is going to give me 56. Now I know that 4x is 56, so what do I have to do to both sides? I'm going to divide by 4 because that cancels, and whatever I do to one side I have to do to the other. And 56 divided by 4, if you don't know that off by heart, this is a non-calculator, so just use the bus stop method. We say, how many times does 4 go into 5? Once, remainder 1. How many times does 4 go into 16? 4 times. So 56 divided by 4 is 14. Now they're saying, find the ratio of J's age to Kiara's age to Martha's age. So we know that J is x, so we can say that's 14. We know that Kiara is x plus 7, so 14 plus 7 gives me 21. And then Martha is 2x plus 14, so 14 times by 2 is 28. And then 28 plus 14 gives me 8 plus 4 is 12, sorry. 2 plus 1 plus 1 is 4. So I'm left with 42. So the ratio would be 14 to 21 to 42. To double check, what must their ages add up to? Well, I'm told that their ages sum to make 77. So if I just did 42 plus 21, that gives me 4 plus 2 is 6, and then 63 plus 14 gives me 77. So I know. So in this question, I'm being told that Emily buys a pack of 12 bottles of water, and the pack costs £5.64. She then sells all 12 bottles for 50p each, and I need to work out her percentage profit. So essentially what she's done is she's gone to a big store, bought them in bulk so that they're cheaper, and now she's selling them off individually to make a profit. Now, in order to work out her percentage profit, I'm first going to need to work out what the total cost is. And they've told me that that's £5.64. I then need to work out what she sells things for. So her total sales, what they amount to. And she's selling 12 bottles times 50p each. So to convert that into pounds, I'll just write it as 0.5. So 12 times 0.5 gives me £6. Okay, so to work out the profit she's made, profit is always sales, take away cost. So £6 take away £5.64 is 36 pence. Okay, so she's made 36 pence profit. Now to work out what the profit is, or percentage profit, we're going to write the profit, divide it by the cost, and times by 100. So what I want to do is 0.36 divided by £5.64, and then times that by 100. And that would give me so the total would be 6.382978 and so on. And it's saying write it correct to one decimal place. So that would be 6.4%. Remember, to write it to one decimal place, you circle the number, look next door. If it's 5 or more, you're going to add one more. If it's 4 or less, you just round it down. Okay, so here I'm told that t equals 4m squared minus 11, and I need to work out the value of t when m is -3. So essentially, I need to substitute -3 into this formula. Now, it always helps to actually just write out what the formula is doing. So 4m squared, what does that mean? It means 4 times by m squared, and then take 11. It's helpful to do this because sometimes people, I don't know, they substitute the -3 and turn it into -43. So think about what the algebra is doing and then work it out. So 4 times by -3 squared, take 11. I'm just doing it bit by bit. So 4, -3 times -3 is 9, and then you take 11. So 4 times 9 is 36, take 11 is going to leave me with 25. So all you're doing is you're just substituting the value into that. This question, I'm told that Hasmeet walks once around a circle with a diameter of 80 meters. So I could fill that in just so that I have some information. There are 8 points equally spaced on the circumference of the circle, and I need to find the distance Hasmeet walks between one point and the next point. So essentially what I'm doing, let's just try and make that a bit thin, I don't know why it was so thick, is I'm trying to find the distance between one point and another point, which is the length of an arc. And how I know that each of these arcs, so this arc, this arc, this arc, this, are all going to total to the circumference of the circle. So first of all, what's the formula of the circumference of a circle? It's always really helpful to just write the formulas out, even if you know them off the top of your head, just because in the exam, people panic, people make silly mistakes. So the formula for the circumference of a circle is pi times diameter. I've been told the diameter, I know that it's 80 meters. So I'm going to do pi times by 80. That's 80 pi, but if I type that into my calculator, it will give me it in decimal form, which is, well, I actually could have divided it. So it's 251.327, or that's a total circumference. Okay, so that is the distance all the way around the circle. But I know that the circle has been divided into 8 parts, so I know that I want 1/8 of the total circumference. So I could either turn it into decimal form and then divide it by 8. It's a calculator paper, so absolutely just do that. Or I know that 80 pi divided by 8 is going to leave me with 10 pi. So whichever way feels better for you, you'll get the same answer. So if I divide that by 8, I end up with 10 pi, which is 31.4159264. So it's just 10 times by the value of pi. And that is what I do for this first part of the question. The key thing is remember what the formula for the circumference of a circle is, and you know the distance, there's 8 equal distances, so you just divide the circumference by 8. Okay, so this is a slightly counterintuitive reasoning question. So I'm told that 4 of the points are moved, as shown in the diagram, and Hasmeet walks around the circle once again. And I need to say whether the mean distance that Hasmeet walks between one point and the next point has changed. Now, I know that from A to B is now going to be a longer distance, and I also know that from B to C it's going to now be a shorter distance. However, how do I work out the mean? The mean is the sum of all the values divided by the number of values. So, because the sum of all of the distances is still going to add up to the total circumference, and I'm still going to be dividing it by 8, the mean will not have changed. So you could say, no, the mean has not changed as the distances between the points still add up to the same value. So it's a bit counterintuitive because we know that the distances have changed. However, the total distances, when you add them together, hasn't changed. The total distances are still going to sum to make the circumference of the circle, and that's why the mean in some instances. So in this question, I'm told the first 5 terms of an arithmetic sequence. An arithmetic sequence just means each term increases by a constant value. So let's have a look at what's happening. It's always helpful to just write it out again yourself so that you can just do some fun stuff. So what we do when we're looking for, and the question is asking you to find the nth term of the sequence, which just means the rule that allows me to find any term. So the first step is I look for what is happening between each term. So how do I get from 7 to 13? I add on 6. Is that the same case for the next term? 13 to 19? Yep, 19 to 25 and 25 to 31. So I know that each time I go to a next term, I'm adding 6. Therefore, this sequence goes up in the 6 times tables. So whatever your constant difference is, that's what you're going to put as your coefficient of n. So I know it's going up in the 6 times tables, but if it was the actual 6 times tables, it would look like this. Okay, so what's different between the actual 6 times tables, which would be 6n, and this sequence? Well, each term is one more than the 6 times tables. So I just write 6n plus 1. To double check if you've got it right, let's see, this is the 1, 2, 3, 4, 5th term. Okay, so n represents the position of the term in the sequence. So the 5th term, n would be 5. 6 times 5 is 30. 30 plus 1 is 31, which is the value of the 5th term. So I know that I've got it right. Okay, so in the next part of the question, I am being told that the nth term of a different sequence is 8 take 6n. And I'm being asked whether negative 58 is a term in this sequence. In order to find out if a term is part of a sequence, what we do is we make the nth term equal to that value. And then we try and solve it to find a value for n. So this is a slightly tricky one because it's got negatives involved. In order to solve an equation, you generally, it's just a lot easier if you make your variable positive. So if we just start by adding 6n to both sides, then you'd be left with 8 equals 58 plus 6n, and then n is positive, and that makes life a lot easier. That's negative 58. Then I can move the negative 58 to the other side by adding. So 58 plus 8 is 66. So 66 is 6n. And then I can divide both sides by 6. 66 divided by 6 is 11. So 11 equals n. Now, if n is a whole number, then it is a term in the sequence. It tells me that negative 58 is the 11th term in this sequence. If when you solved it and you found that n was, let's say, 11.2, then it isn't a term in the sequence because you don't have an 11.2th term. Okay, terms in a sequence are always going to be integers, whole numbers. In this question, I'm told that this diagram shows a plan of Jason's garden. And I know that ABCO and DEFO, so these over here, are rectangles. Then I am told that AFO is a sector of a circle with center O and angle AOF 90 degrees. So I know this is a 90-degree angle. I know that angles in a circle sum to 360. So if it's a 90-degree angle, that must mean it's a quarter of a full circle. And then AFO, yeah, we've done that. And then I've just got the triangle as well. So I'm being told that Jason is going to cover his garden with grass seed. So this whole shape here needs to be covered with grass seed. Each bag of grass seeds covers 14 meters squared of garden, and it costs £10.95. I need to work out how much it will cost Jason to buy all the bags of grass seed he needs. So in order to do this, the first thing I need to do is work out the area of the whole garden. Okay, so first part is just going to be the rectangles. So the area of a rectangle is base times height. So for here, that would be 77 meters squared. 9 times 7 is 63, so this would be 63 centimeters squared. Then for the circle, how do you work out the area of a circle? The formula is pi r squared, where r is the length of the radius, and because it's a quarter of a circle, you're going to have to divide by 4. So what's the radius of this? Well, I know that this length here is 7, therefore this length here must also be 7. So I'm going to do pi times by 7 squared and then divide that by 4. So that would be 49 pi over 4. And I can just type that into my calculator. So 49 pi times by, divided by 4 gives me 38.48. So this would be 38.48451001. I can deal with rounding later. And the last part I need to do is the area of this triangle here. So once again, I'm going to have to use the other measurements that I've been given. I know that this length is 9, so this will also be 9, and I know that this length is 11, so this will be 11. What's the area of a triangle? Similar to a rectangle, but a triangle is essentially like half a rectangle. So what am I going to do? Area of triangle is base times height divided by 2. So I'm going to do 9 times by 11 divided by 2, which is 99 over 2. So once again, I've got my area, and that would just be 49.5 meters squared. So what I want to do is work out the total area of the garden. So the total area of the garden, I'm going to add all my individual areas up. So total area is 77 plus 63 plus 49.5 plus 38.484. Or I could have just left that as 49 pi over 4. So let's add all that together. 63 plus 77 plus 38.48451,001. And that gives me 227.98451. So that is the total area of the garden. Now I know each bag of grass seed covers 14 meters squared. So what I want to do is figure out how many, and I'm going to just divide it. So keep your answer on your calculator and then you can just divide. So I'm going to divide that by 14, which tells me I'm going to need 16.284 bags of grass seed. Now, when I go to a shop, it would be very nice if I could be like, oh, hey there, could I just have 0.28 of a pack? Because I'm not actually going to use all of it. So can I just pay for what I'm going to use? But that's not how life works. If you go and you buy a bag of grass seeds, you have to buy the whole bag. So because it's real life, we're going to need to round this up to 17. Obviously, if we were just rounding numerically, 16.2 would round down to 16. But in real life, you need to use everything. So I'm going to need to buy 17 bags of grass seed. And I'm told that each bag costs £10.95. So 17 times by £10.95 gives me a cost of £186.15. Okay, so that's how I do that. So you just break up the question, work out the area of each individual little part, divide it by 14 to figure out how many grass seeds needed, and multiply it by 10 points. So standard form is when I'm writing either really, really, really large numbers or really, really small numbers in a way that I can compare them easily. So write 1.63 times 10 to the power minus 3 as an ordinary number. This little indice, if it's a negative, it shows you it's going to be a small number. So you know you're going to be looking at a decimal number. So what we do when it's a negative number, we start with 0. And whatever this little number here is, that's how many zeros we want to write before our number starts. So we'd write 0.00163. Because it says minus 3, there are 3 zeros before I start writing my number. And that's how we'd do that one. So 0.00163. Then we're being asked to write 438,000 in standard form. So to write a number in standard form, generally the rule is it needs to be a number between 1 and 9.9 times by 10 to the power of something. Okay, so let's turn this into a number between 1 and 9.9. Generally, you just put a decimal point after the first digit. So 4.38 times by 10 to the power of, and what we do is we just count how many digits are after the 8. So 1, 2, 3, 4, 5. I meant to say after the 4. So 4.38 times 10 to the power 5. If you're not sure about standard form, there's another video which explains how exactly you do it. So sometimes you're going to be asked to do calculations with standard form. So here you're asked to multiply two little brackets that have standard form in them. Because everything is being multiplied, what you can do is just write it out as one large multiplication like this. And then you can just multiply the things together that make life easier for yourself. So 4 times 6, you know, would become 24. And 10 to the power of 3 times 10 to the power of negative 5. When you're multiplying indices, you add the powers together. So 3 plus minus 5 is going to give you minus 2. So that would be 24 times 10 to the power of minus 2. Now, they've told you to give your answer in standard form. And this is a little mean little thing that they sometimes do, because you're obviously in the exam and you're like, oh, I found the answer, but you haven't written it in standard form. So you always need to make sure this number is a number between 1 and 9.9. So I have to turn this into 2.4. And what have I done in order to turn this into 2.4? I have divided by 10. Okay, so whatever you do to one side when you've got a standard form, you do the inverse to the other side to keep it balanced. So I've divided 24 by 10 to get it to 2.4. So I'm going to have to multiply this side by 10, which means each little so like 10 to the power of 3, 10 squared. Each time you go up, you're multiplying by a power of 10. So that would become 10 to the power of minus 1. And that's your final answer. So 2.4 times 10 to the power minus 1. So in this question, I've been given a Venn diagram, and I'm told that the universal set, this strange little squiggly symbol, just means the universal set. It means everything that can possibly be in the Venn diagram. So it's helpful to list out what that is. So numbers between 1 and 20 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now the numbers that are in set A are multiples of 3 or 5. So let's start with the 3 times tables. That would be 3, 6, 9, 12, 15, and 18. And then the 5 times tables, well, that's 5, 10, 15, and 20. Okay, so in set A are going to be all of these numbers. And then set B is the factors of 20. So I could just do a quick little factor tree. So I know that would be 1 times 20, 2 times by 10, and 4 times by 5. So the factors of 20 are 1, 2, 4, 5. So 5 gets circled twice. So let's be mindful of that. 10, which also gets circled twice. And 20, which also gets circled twice. So the numbers that get circled twice are what are in the intersection. They are common to A and B. So I'm going to write 5 and cross it out just so I don't forget. 10 and 20 in this intersection here. Then everything else, all the numbers that are part of A, I've circled them in a different colour so I can conveniently just write them in. That would be 3, 6, 9. And let's cross them out. 3, 6, 9, 12, 15, and 18. And then the numbers that are just factors of 20, so they're the dark green ones, that would be 1, 2, 4. And is there anything else I've circled? No. So what that means is that all of the other numbers have to go on the outside. So I've got 7, 8, 11, 13, 14, 16, 17, and 19. Okay, in total there are 20 numbers. So you might just want to double check by seeing if there's 20 numbers in there. And that's how we'd fill out the Venn diagram. Now the next part is saying list the members of A union B. Now, really quick recap on probability notation. If you've got this, that means the union. So it essentially means in your Venn diagram, everything that is in A or B or both. Okay. And I tend to sort of, just a silly little way to remember it, union looks like a valley. It doesn't really, but you can imagine it being valley. Valleys in this country are very common. So it's very common. So it means lots and lots of things can be present in it. The other type of notation is this, a intersection. So that is the intersect. So it essentially means anything that is in A and B. So it has to be in both of them. So that is just going to be anything in that little intersect there. So I am being asked to list the members of A union B. So everything that is inside here. So that would be 3, 6, 9, 12, 15, 18, 5, 10, 20, and then 1, 2, 4. Okay, so everything that's in that little bit there, that is the union. And then I'm asked or told a number is chosen at random from the universal set. The universal set just means everything in this Venn diagram. And I know that there's a total of 20 numbers, so I know it's going to be out of 20. This thing here, if you see P and then something, that just means the probability of and whatever's in the bracket. Now, the last thing about set notation is if you see something like this, that means not. So the probability that it is not in B. So B is over here. So I want the probability that a number is not in B, so I can just cross those out. And then what am I left with? I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So the probability of a number not being in B is 14 over 20. Okay, so in this question, I am told that Karina has 4 tanks on her tractor and that each tank is a cylinder with diameter 80 centimetres and height 160 centimetres. I'm told that the 4 tanks are to be filled completely with a mixture of fertiliser and water, and the fertiliser has to be mixed with water in the ratio 1 to 100 by volume. Karina has 32 litres of fertiliser, and does she have enough fertiliser for the 4 tanks? So the first thing that I want to do is figure out what the total volume of the tanks are. So how do I work out the volume of a cylinder? Well, to work out the volume of any prism, what you want to do is work out the area of the cross section, and you multiply that by the length or the height or whatever you call it, the bit that isn't involved in the area of the cross section. So what's the area of this cross section here? That's a circle. The formula for the area of a circle is pi r squared. So I know that the diameter of this circle is 80 centimetres, and a diameter is 2 lots of the radius, so therefore the radius must be 40 centimetres. So I can just substitute that into my equation. So the area is going to be pi times by 40 squared. Now I can just leave that in terms of pi for now because I'm not being asked to round anything yet. I only want to round at the very end. So 40 squared is 1,600. So that area of the top part is 1,600 pi. Now what do I do to work out the volume? Well, I work out the area of the cross section, which is 1,600 pi. And then I multiply it by the length, which is 160. So 1,000, so the volume is going to be 1,600 pi times by 160. And 1,600 pi times by 160 gives me 256,000 pi. Now that's the volume of one cylinder, and I have 4 cylinders, so I'm going to multiply that by 4, which leaves me with quite a large number, 3,216,990.877 centimetres cubed. Now I've been given a vital piece of information, which is that 1 litre is equal to 1,000 centimetres cubed, and that's because 1 millilitre is equal to 1 centimetre cubed. So what I want to do to turn my centimetres cubed into litres, I'm going to divide by 1,000 to get it to litres. So divided by 1,000 gives me 1,024 pi. So I know that the total volume of all 4 cylinders is 1,024 pi. I could convert it into decimals if that makes life easier for you. So that would be 3,216.990877 litres. Now, I know that the fertiliser has to be mixed with water in the ratio 1 to 100. So 1 part fertiliser to 100 parts of water. So in total, I have 101 parts. So what I want to do to work out how much fertilizer I need is divide by 101. And that gives me 31.85139,482. So I need 31.85 litres of fertilizer in order to fill these tanks correctly. She has 32 litres of fertilizer, so I would say yes, she has 31.85 litres. Okay, so next I've got a percentages question. I'm told that the price of a festival ticket increases by 30% and the new ticket price adds £99 to the total cost of the festival ticket. So therefore I know that 30% is equal to £99. Work out the price of the festival ticket before the price is increased. So if I know that 30% is equal to £99, what I can do is just find 10%. And how do I do that? Well, 30% divided by 3 gets me to 10%. So I'm going to divide this side by 3 too. So I know that 10% is £33. If I know that 10% is £33, I can then find what 100% would be. I'd multiply 10 by 10. Because that gets me 100, so I have to multiply this side by 10 as well, and that would be £330. In this question, you're being asked to first of all rotate trapezium T 180 degrees about the origin, and the origin is just the point 0, 0. So I'm going to do my rotation around here. Now, I don't have a virtual tracing paper that I can show you, but what you do is you take your tracing paper, you put your pencil on the origin, you draw a rough sketch outline of this, and then you turn the page a quarter turn. So a quarter turn is 90 degrees and a half turn is going to be 180 degrees, just like the degrees in the circle. So if you did that, you would then end up with the coordinates over here and your trapezium. I'm just going to get rid of the fake tracing paper. Would look like this. Okay, so you've got your tracing paper, you mark the little points, and that's how you do your rotations. So they're nice and simple, and you mark that A. Then I'm told to translate trapezium T by the vector -1, -3. Now remember, vectors, they tell you the distance, the distance and the direction. So all vectors are written with their X instruction at the top and their Y instruction at the bottom. And if it's a positive X, I don't know why I did an up arrow. If it's a positive X, it's going to go in the right direction. If it's a negative X, it's going to go in the left direction. And if it's a positive Y, it's going to go up. And if it's a negative Y, it's going to go down. So I've been given the instruction -1, -3. So I know it's going to go 1 to the left and 3 down. So sometimes helpful to just write the instructions out so that you don't just get confused in the exam flurry. So pick one point on your trapezium and I'm going to translate it 1 to the left and 3 down. So 1, 2, 3. And that's going to be that point. Now, if you're feeling confident with just drawing the shape, you can just draw it like that because you know the lengths of all of the sides. But if you need a bit more confidence or you just want to double check, pick another point, go 1 left and 1, 2, 3 down. And then you can feel confident that you've done it. So that's how we do that. Okay, so in this question, I'm told that Ella invests £7,000 for 2 years in an account paying compound interest. Now, compound interest just means that at the end of the year, you gain interest on the total value of everything in your account rather than just the initial investment. So it means each year your money's building and building and building. Now, in the first year, the rate of interest is 3%, and in the second year, the rate of interest is 1.5%. I need to work out the value of Ella's investment at the end of the 2 years. So when I do compound interest, the best thing I can do is turn my percentage into a multiplier. So I start with £7,000 and then that is increased by 3%. So if your original value is 100% and you increase it by 3%, in total, you're trying to work out 103%. And what does percent mean? It means over 100 So I could just type that into my calculator. 103 over 100 is 1.03. So it's really important to get your multipliers right. So the first year, I do 7,000 times by 1.03. And for the second year, there's an interest rate of 1.5%. So once again, I can just think, okay, if I've got 100% and I add on 1.5%, that would become 101.5%. 101.5 over 100 gives me 1.05. Okay, so that's how I'd work that out. So the key thing is thinking about how you turn your interest into a multiplier, and then you just multiply your amounts. So you type them into your calculator. So 7,000 times by 1.03 times by 1.015 gives you £7,318. Index laws over here. So it's helpful to just write out the things that we remember. So with my index laws or laws of indices, the law of multiplication is that when I'm multiplying indices, I can add the powers together. So I know that p to the power of 3 times by p to the power of x equals p to the power of 9. Therefore, p to the power of 3 plus x must equal p to the power of 9. And what I can do is just look at this, equate it to this. So I know that 3 plus x must equal 9. If I subtract 3 from both sides, I know that x must be equal to 6. I can always double check it. So does p to the power of 3 times p to the power of 6 make p to the power of 9? Yes, because 3 plus 6 makes 9. For the next one, we've got the law of brackets. So when you're multiplying indices in brackets, the quick shortcut version of the law is whatever the power is inside the bracket, you multiply it with the power on the outside of the bracket. So that would become a m times m. So I know that 7 to the power of 2 times by the power of y is the same as saying 7 to the power of 2 times by y. And I know that equals 7 to the power of 10. Once again, I can make my little equation. I know that 2 times y must equal 10. So therefore, I can solve it. And if I divide both sides by 2, I know that y equals 5. Okay, so this next question is slightly trickier, so I just changed it on so it has a whole slide of its own. So questions like these are becoming a little bit more common. They are quite unconventional and they're maybe not what you're used to seeing. But the key thing is whenever you have any index laws, one of the key fundamentals is that they must have the same base. So in order for you to use index laws, numbers must have the same base. And hopefully you see that the base over here is 100 and the base over here is 1,000. Therefore, the laws of indices cannot work on this calculation unless I manipulate it so that these numbers are rewritten as something that has the same base. Now, it's 100 and 1,000. Some people might think to themselves, oh, I could write it as 100, both as a base of 100 because 100 times 10 makes 1,000. But if you did write it as 100, then you can't really, you'd be multiplying it by 10 to the power of 1 and you can't compare them so well. So the best thing to do would be to write them as powers of 10. So how do you write 100 as a power of 10? Well, 100 would become 10 squared, okay? And that would end up being to the power of a. So all I've done is instead of saying 100 to the power of a, I've rewritten 100 as 10 squared. Now what I want to do is do the same thing with 1,000b. So what's 1,000 as a power of 10? Well, 10 times 10 times 10 is 1,000. So therefore I could rewrite that as 10 cubed to the power of b. So all I've done is I've written my calculation so that I now have common base numbers because then the laws of indices apply. And I know that this can be written in the form 10w. So now what do I do when I am multiplying indices in brackets? Well, I multiply the powers. So that would become 10 to the power of 2a times by 10 to the power of 3b must be equal to 10 to the power of w. And what is the law for multiplying indices? When I multiply indices that have the same base, I simply add the powers. Therefore, I can form an equation, and 2a plus 3b must be equal to w. And the question is asking me to prove that w equals 2a plus 3b, and that is how I would do it. I could rewrite it as w equals 2a plus 3b if I'm being pedantic, but they mean the same thing. So the trick is always think to yourself, oh, okay, these numbers don't have the same base. Therefore, let me see if I can rewrite them. 10 is a nice common factor of both of them. I can rewrite both of them as a power of 10. Here I've got an error interval, but it's a slightly different one that people frequently just overlook, because truncation is kind of like this weird thing that you're like, why do I do this if I know how to round? So when I truncate, let's just give a random example, 6.47983. When you truncate, you literally chop off where it says, so to one decimal place, if you truncated it, you literally just would write that as 6.4. You don't consider rounding at all. If it was to 2 decimal places, it would be 6.47. And if it was to 3 decimal places, it would be 6.479. So you literally just chop off anything after your decimal, and you just leave it as it is. You don't worry about rounding. So that's what truncation means. So I know that crisps are packed into 30-gram bags, okay, truncated to the nearest gram. So what that must mean is that it's rounded to the nearest decimal place. So the lowest possible value it could be, if I think about my decimal places, it could be 30.000986, blah, 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 blah. So the lowest possible value it could be is 30, because if I truncated it, the first digit could be 0, the second digit could be 9. It doesn't matter because I'm truncating. So the lowest possible value would be 30. If it was 29.99 whatever, then to the nearest gram, I would have just truncated it to 29. So that's why 30. And then, because it's been truncated to 30, I know that it must be 30 point something. The highest possible value it could be is 30.9 recurring. But because the error interval says less than, I'm going to say it would be 30 to 31, because it could technically be 30.9 recurring. So anything under 31 is what it could be. And that's how I do an error interval with truncation. In this question, I have been given a trapezium and I'm asked to work out the size of angle CDA. So it's always really helpful to just start by colouring in the angle that you're being asked to work out. So CDA is this angle here. Now, I'm asked to work that out and give my answer to 1 decimal place. So what can I do in order to work out this angle? Well, in order to work out an angle, I want to use a triangle. So I'm going to have to figure out information about this triangle here. So I can just form this as a nice triangle. And if I'm dealing with right angle triangles, I know it's a right angle because, well, it's a trapezium, and I know that this line here is a right angle, so therefore this one would be a right angle too. So let's have a think. What information do I know and what information can I find out? I know, first of all, that over here I've been given a right angled triangle, and I know the length of one side, another side, and this length here I do not know. So when I've got a right angled triangle, I can either use Pythagoras, and that is going to be if I know the lengths of 2 sides and I'm trying to work out the third side. I'm going to use trigonometry if there's angles involved. So with Pythagoras, I know that a squared plus b squared is c squared. That's Pythagoras' theorem. Whenever you have the longest side, so you always know which side is the longest because it's the side that is opposite the hypotenuse. Whenever you have the longest side, you rearrange the equation. So c squared take away a squared must equal b squared. I can substitute that in. So 7.5 squared take away 6 squared is going to give me b squared. And remember, the sides don't matter, a and b, it doesn't matter, they're both just the shorter sides. So 7.5 squared take 6 squared gives me a value of 20.25. So to work out b, the final step is to do the square root, which gives me square root of answer is 9/2, which is 4.5. So I now know that this length over here is 4.5. I don't know if I've drawn over it, but whatever that would have been. Have I drawn over it? No. So I can just call that length 4.5. I'll just label it there. I don't have to call it anything. Now, the reason I found that is because in order to find this length here, I can only do that if I know this total length here. And I don't know that. I only know that this length is 10. Okay, so if I know the total length here and I subtract this length, this total length, I would be given the length, is that C? This is what? No. Once again, they haven't labelled everything, but it doesn't matter. I'd work out that length here. So the total length of the bottom of the trapezium is 24 centimetres. I know that this length here must be 10 centimetres because it's equivalent to its upper part. So 24 take away 10 take away 4.5 is going to give me the missing length that I need. And 24 take away 10 take away 4.5 gives me 9.5. So I know that this little bit of my triangle that I'm trying to work out is 9.5 centimetres. And it sometimes helps to just draw out the triangle again separately to what you're doing. So I know this length is 9.5. This is the angle that I'm trying to work out. So what other information would I need to know? Well, I'd either need to work this out or this out. And thankfully, if I just get rid of all of the scribblings, I have been given the height of the trapezium. So I know that this height here must be 6 centimetres because this height here is 6 centimetres. So this length here is going to be 6. Now, if I know two sides and I'm trying to work out an angle, then I can use trigonometry. So with trigonometry, the best advice I can give you is to actually just write out your SOHCAHTOA, because the amount of people, including myself, that just make mistakes because you're rushing and you just mix up the sides by accident. So which sides have I been given and what am I trying to find? Well, this is my given angle, so I label everything accordingly. So this 6 is opposite my given angle, and this side here is adjacent to my given angle. Which ratio uses the opposite and the adjacent? O and A, that's tan. So I can write out that tan theta must equal the opposite over the adjacent. And remember, theta is just the sign for an angle from the Greek alphabet. So tan theta, if I substitute my values in, the opposite is 6 and the adjacent is 9.5. And whenever I'm trying to work out an angle, I always have to do this thing called, like in your calculator, you press shift and then tan. It's the inverse of tan. It's the same as dividing by tan, but our calculators don't like it when we do that. So we press shift tan. So I'll write that here. You press shift tan and then use the fraction button to write 6 over 9.5. So 6 over 9.5, close the bracket because otherwise you won't get the calculation, and that gives me a value of 32.2756. They want it to one decimal place, so again, circle the first digit, look next door. If it's more than 5, you're going to round up, so that would be 32.3. Okay, so in this question, I have been told that circle A has a diameter of 20 centimetres. Circumference of circle A to the circumference of circle B is in the ratio 2 to 5, and I then need to work out the area of circle B. So in this question, it's really helpful to think back to the formula for circles, circumference and area. So the formula for the circumference of a circle is pi times by the diameter. This is also going to be on your formula sheet, so you can use that if you don't know this off by heart. And the formula for the area of a circle is pi times by the radius squared. So it's just really helpful to just write out the things that you know so that they can help you in the question later on. So I know that the circle A has a diameter of 20 centimeters. How do I find the circumference? Well, the circumference is going to be pi times by the diameter. So the circumference of circle A is 20 pi. I know that the circumference of circle A to circle B, so A to B, is 2 to 5. So if the circumference of circle A is 20 pi, that must mean that the circumference of circle B, what have I done to 2? I've multiplied it by 10 pi. So I'm going to have to do the same on this side. So the circumference of circle B would be 50 pi. So I know the circumference of B is 50 pi. Now, how do I find circumference? It's literally pi times by the diameter. Therefore, I know the diameter of B is 50. Now, I need to work out the area of the circle, and in order to work out the area of the circle, I need to find what the radius is. The area is pi times the radius squared. Now, just as a quick recap, the radius is the line from the center of the circle to the outside, and the diameter is a line from one side of the circle to the other going through the center. So a diameter is 2 lots of the radius. So now that I know that the diameter is 50, I know that the radius of circle B is going to be 25 centimeters. So I can use that in my formula and find the area, and I leave my answer in terms of pi, so I don't need to worry about pi. So what am I going to have to do? I'm going to have to do pi times by 25 squared. So really quickly, 25 times by 25, you can multiply this however you like. You might also know that it's 625 because you're great at your square numbers, but if not, then 5 times 2 is 10, 5 times 5 is 25, 2 times 2 is 4, and 2 times 5 is 10. Extend your line, so that would be 5, 2, 6. Okay, so I know that the area is going to be pi times by 625, which is 625 pi. So all of these things you know how to do. It's just about recognizing what formulas do you already know and how can you use them in these questions. And that's how you need to attack all of the questions. What do you know and what can you use? At least you can pick up some marks for some of the simpler things. Okay, so here we've got a slightly complicated looking indice, but if we just break things down bit by bit, applying all of the things that we know, we can go through this question. So the first thing that I probably want to do is think back to my index laws. So I know that when I'm multiplying indices, I just add the powers. So if I had a to the power of m times a to the power of n, I would end up adding the 2 powers. So using that, I can simplify the denominator. So 10 to the power of 150 times by 10 to the power of 90 must equal 10 to the power of 150 plus 90, which is 10 to the power of 240. So I can rewrite this as the square root of 10 to the power of 360 over 10 to the power of 240. Next thing I could do is use my next index law. Over here, I'm dividing the indices. So when I divide indices, what do? I subtract the powers. So I could write 10 to the power of 360 divided by 10 to the power of 240 must equal 10 to the power of 360 take 240, which is 10 to the power of 120. So I can rewrite this as 10 to the power of 120. And the final bit, and this is where it gets into the higher powers. So whenever you've got something written as the square root, when I have the square root of any number, I can rewrite that as a to the power of a half. So therefore, I could rewrite this as 10 to the power of 120 to the power of a half, because it's all, the whole thing, everything inside the square root is being square rooted, so it's all to the power of a half. And what do I do when I've got indices in brackets? Well, a to the power of m to the power of n, I just multiply the indices together. So I'm going to do 10 to the power of 120 times by 0.5. You can leave it as a half if you want. I just root at 0.5 becomes 120 times by 0.5. Timesing by 0.5 is the same as dividing by 2, so that would become 10 to the power of 60, because 120 times 0.5 is 60. And you've just expressed that as a power of 10. So you've worked out each tiny little bit that takes you one step closer to working out the final bit. Okay, so over here, I'm told that Liam was asked to express 12 to the power of 50 to the power of 2 as a power of 12. Liam wrote 12 to the power of 50 times 2 equals 12 to the power of 50 squared. Okay, so what did he do wrong? Well, Liam did 50 squared. Don't know why he did that. When you are multiplying indices in brackets, you multiply the powers. Whereas he squared them. He did 50 squared. So his method is wrong. What should it have been? Well, 12 to the power of 50 to the power of 2. What do? I multiply the indices, so that should have become 12 to the power of 100. Okay, so what did he do wrong? Instead of multiplying 50 by 2, he did 50 to the power of 2. Okay, so in this question, I'm told that James and Peter cycled along the same 50 kilometre route. So both of them cycled along a 50 kilometre route. James took 2.5 hours. So I could just write that as a decimal, 2.5 hours to cycle the 50 kilometres. Okay, so I'm then told that Peter started to cycle 5 minutes after James started to cycle, and he caught up with James when they had both cycled 15 kilometres, and that they both cycled at constant speeds. So what I can first do is figure out what James's speed must be, because I have all of the information that I need in order to do that. So remember, speed is distance over time. So then the distance is 50 and the time is 2.5. This is a non-calculator paper, so you could, you could either do 50 divided by 2.5 if you're confident with dividing decimals, turn that into 500 divided by 25, or you could turn it into a fraction. So 50 is being divided by 2.5. So 50 is being divided by 2.5. If I turn that into an improper fraction, that would be 5/2. So 50 is being times by 2/5. So that would be 100 divided by 5, which is 20. So James's speed is 20 kilometers per hour. So let's just write that up here. And then what I need to do is compare it. So I know that James cycled at a constant speed of 20 kilometers per hour. And then Peter started to cycle 5 minutes after James started to cycle, and he caught up with James when they had both cycled 15 kilometers. So that means that, okay, so now I need to figure out how long it took Peter to cycle 15 kilometers. So I know, James, I know that James's speed is 20 kilometers per hour. So I know his speed, write the formula up again, speed is distance over time. So speed is distance, 15 over time. I don't know his time yet. How can I work out what the time is? I can switch these around. So the time is going to be 15 over 20, which would simplify to 3/4. Okay, so that means that it took him 3/4 of an hour. 3/4 of an hour is 45 minutes. So Peter started to cycle 5 minutes after James started to cycle. So that means that he must have done the 15 kilometers. So Peter's speed, he must have done the distance, 15 kilometers, in 40 minutes, because he started to cycle 5 minutes after James. So we take 5 minutes and it's 40 minutes. But remember, when you're dealing with time and speed, you always want to write your time in terms of hours. So the 40 minutes we're going to need to turn into hours. So what you can do is write that as a fraction of an hour, because there's 60 minutes in an hour. So 40 over 60 would be 4/6, which would simplify to 2/3. So to find out Peter's speed, what I would need to do is 15 divided by 2/3, because 40 minutes is equivalent to 2/3 of an hour. And once I'm dividing decimals, what do? I keep, change, flip. So that would become 15 times by 3 over 2. 15 times by 3 is 45. And 45 divided by 2. If I can't do it in my head, just use the bus stop. So 2's into 4 go twice. 2's into 5 go twice, remainder 1. And 2's into 10 go 5. So therefore Peter's speed is 22.5 kilometers per hour. So this one is quite a tricky question, because there's a lot to read or interpret. But we start by just figuring out what James's constant speed must be. Then we need to figure out how long it took him to cycle 15 kilometers. And then using that, we can finally figure out how much time it took Peter. And the key thing to always remember with speed distance time is whenever you're dealing with minutes, you want to convert them into hours. And you do that by writing it as a fraction. Okay, so in this question, we have got quite a complicated looking solid. We are told that a cube is placed on top of a cuboid. So the key thing about the cube means that all sides are going to be the same. And it is shown in the diagram to form a solid. Now the cube has edges of 4 centimeters, so we know all of these little edges are going to be 4. The cuboid has dimensions 7 by 6 by 5, so we know all of the dimensions of the cuboid, and we need to work out the total surface area of the solid. Now the surface area is every part on the outside of the solid. If you imagined you were wrapping this as a Christmas present, the surface area is the area of all of the faces, all of the surface that you would put wrapping paper over. So we know it's generally going to be the majority of the cuboid. Aside from this top face, there's going to be something funky going on there, and then the majority of the cube. So let's start with the cube. We know that 5 of the faces, if we try and visualize this, we've got the back over here, the front over here, then we've got the top face over here, and then we have this side face and this side face as well. So we've got 5 faces that all have an area of 16 centimeters squared. 4 times 4 is 16. So we know that we have to do 5 times by 16, which is 5 times 6 is 30, 5 times 1 is 5, plus 3, 80. So we've got 80 centimeters squared there. And now let's try and work out the surface area of the easy parts of the cuboid. So the cool thing about a cuboid is that the front and the back face are going to be the same, the 2 sides are going to be the same, and the top and the bottom are going to be the same. So let's start with the back face over here. So that's got a length of 5 and a width of 7. So I'd do 5 times 7, and the front is going to be exactly the same. So that's 5 times 7 as well. So I can do 5 times 7 times by 2, or I can just draw them out both, whichever way you prefer. So 5 times 7 is 35. I've got 2 lots of them. So I've got 70 centimeters squared there. Now let's do the side faces. So over here, I've got 5 times by 6. And then over here, I'm going to have exactly the same, 5 times by 6. So an area of 30 centimeters squared. And there's 2 of them, so a total of 60 centimeters squared. So I've worked out 4 faces of the bottom cuboid, or the only cuboid. And then let's just work out the area of the base. So the base down here, 7 times 6 is 42 centimeters squared. Now the tricky bit here, and this is the part that lots of people just get a bit confused by, is they're like, what do I actually have to work out here? Well, if you think about it, you've got this large cuboid here, and all of this area you need to work out, but you do not need this area here, which is the area of one of the faces of the cube. Now we know that the faces of the cube are 16 centimeters squared, and we know that the the area of the bottom is 42. So if we did 42 centimeters squared, subtract the small face that we're not using, 16 centimeters squared, it would leave us, oh, why did I undo everything? It would leave us with the pink bit, which is the area that is not covered. So the base of the cube and the top bit, they're kind of cemented to each other, so we don't include them in our surface area. So 42, take away 16, 2 take 6 you can't do, so 12 take 6 is 6, 3 take 1 is 2. So let's call it the random face is 26 centimeters squared. So now what we have to do is just add all of that together. So 80 plus 70 is 150. 150 plus 60 is 210 centimeters squared. And then we can do 210 plus 42 plus 26. So 2 plus 6 is 8, 4, 5, 6, 7, and 2. So the total surface area is 278 centimeters squared. There's other ways you could have done this too. You could have worked out all of the area and subtracted that bit, but if you got an answer of 278, that's absolutely okay. So in this question, I'm told that Aaliyah bought a car. In the first year after she bought the car, its value depreciated, which means goes down in value or went down in value, at a rate of 23% per annum, and that just means per year if you weren't sure what that meant. And in the second year, the value depreciated at a rate of 19% per year. At the end of the second year, the car was worth £10,914.75, and I need to find out what the value of the car was when Aaliyah bought it. So I don't know what the value is, but whatever the value is, so remember, whenever you don't know the value of something, you can just use a variable, use algebra. So whatever the original value was, multiplied by my original year multiplier, then by my second year multiplier, must give me £10,914.75. Now I've told that in the first year it depreciated at a rate of 23% per annum. So what does that mean when I'm thinking about my multipliers? Well, if I started with 100% and it fell by 23%, that means that I'm actually left with 77%. What does percentage mean? It means over 100. So as a multiplier, that would be 0.77. So that's for the first year. For the second year, it depreciated at a rate of 19%. So again, I do 100 take away 19, which is 81. And 81% means 81 over 100, which would give me a multiplier of 0.81. So now I've got this equation. I know that x times by 0.7 times by 0.81 must give me 10,914. So you could do, well, you could do lots of things, but you could multiply these two terms together first. So you know that x times by 0.77 times 0.81 gives me 0.6237 must equal £10,914.75. To solve the equation, what I need to do is divide both sides by 0.6237, and that will allow me to figure out what x is, which is the original value. So £10,914.75 divided by my answer is 17,500. So next question is a cumulative frequency. It we are told that the table shows some information about the profit made each day at a cricket club on 100 days. So we know that the total frequency is 100. Now, cumulative frequency, all that means is like the running total. So we just add everything on top of each other. So from 0 to 50, we know we have a frequency of 10. Then from 0 to 100, what that means is we want all of this data. So 10 plus 15 is 25. And then from 0 to 150 means we want all of this data. So we'd add 25 to our total, which is 50. Once again, we want it up to 200, so we add on 30, which is 80, then we add on 5, which is 85, and we add on 15. We know we are correct if our total frequency adds up to the total frequency that they told us. So 100 days. So now what we need to do is plot this on the graph above. I'm going to have to flick between both sides. So our first coordinate is going to be 50, 10. Just a quick note, the coordinates, you always do them with the end point of the class interval. So the first coordinate is going to be 50 and then 10. Okay, with frequency polygons, you do the midpoint, but with a cumulative frequency graph, it's always the last part of the class interval. So the largest value essentially. So first point is 50 and then 10. Then I've got 125. So over here, then I've got 150 and 50. Ooh. And then 280. 280 is over here. And then I've got 250 and 85. And then I've got 300 and 100. Just a quick note, sometimes people struggle with identifying the what each little square is worth. So generally what you want to do is find the difference. So the difference between 180 is 20, and count how many little squares there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares. So 20 divided by 10 is 2. So that means each little square is 2. So that's how you work that out. Now with a cumulative frequency, we start from 0 and we join it up with a smooth curve. Okay, never a straight line. Oopsie, even that's not good. So let's start again. So you join it with a smooth curve and it should look like, generally like an S shape. Okay, now here comes the fun part. We are asked to use the graph to find an estimate for the number of days on which the profit was less than 125. So they tell us which axes to use because it says we want to know the number of days, so that's what we're trying to figure out, on which the profit was less than 125. So we go along the x-axis to where the profit is 125, which is here. Okay, we draw a line up to the cumulative frequency and then we go across. Now mine might not be so accurate because it's like thick lines on a small iPad, but you always get a range of accuracy for your answers anyway. So let's see what that would be. So that would be 30. I know that each little thing is 2, so that would be 32. Ooh. 4, 6, 36. So that would be 36 days. Yeah. Obviously, I think I don't know the exact range, but maybe 35 to 38 would be fine. Your graph will be a lot more accurate because you've got the actual paper in front of you. And then we are asked to find an estimate for the interquartile range. Now, whenever we're finding the median or the upper quartile or the lower quartile, we always use the y-axis. We always use the cumulative frequency. So what we do is we have to find the upper quartile. Now, the upper quartile is the top 75% of data. The lower quartile is the lowest 25% of the data. So the median would be 50%, 75% would be 75. So over here, I'm going to go to 75. So that would be 70. And then 2, 4, 5 would be right in the middle there. And I'll use a different color. And then we go down. Now, it is a little bit annoying. Mine won't be super accurate, but you'll get it on yours and you'll see exactly what it should be. So that's 175. And once again, let's work out the difference to figure out what it's going up in. So it's a difference of 25, and there's 5 boxes, so each little box is 5. So that's 175, 180, 190, roughly. So the upper quartile is 190, and then the lower quartile would be 25. If this is a really nice cumulative frequency graph because it goes from 0 to 100. If it was 80, you just work out 75% of 80, and that would be your upper quartile, and then 25% of 80, that would be your lower quartile. So here we've got 25, so that would be 30, and 25 would be over here. We go across, and it says it's 100, so let's just trust it. Yours are going to be more accurate, but you get what I'm trying to do, hopefully. So the interquartile range is the difference between the upper quartile and the lower quartile. So you'd do 190, take away 100, which is 90. Okay, so here I've been told that I have a sector of a circle with radius 3 centimeters and an area of 1 4/5 pi. I need to work out the size of the angle XYZ. Well, what are the formulas that I know for sectors? I know that the area of a sector is theta, which represents the angle, over 360 times by pi r squared. And the reason for this is you're just saying what fraction of the circle am I working out. Like if I had to work out a quarter of the circle, I would use the formula pi r squared, and I'd divide it by 4, which is the same as multiplying by a quarter. So we're always just trying to figure out the fraction of the circle, which is this, and then we multiply that by the area of the whole circle. So let's fill out the information I know. I know that 1 4/5 pi is the area. So just to make life easier, I can turn it into an improper fraction. 5 times 1 is 5, plus 4 is 9. So 9/5 pi is the area of the sector. And I know that theta over 360 times by pi r squared. Do I know the radius? They've told me that the radius is 3 centimeters. So I'd say 9/5 pi is theta over 360 times by 3 squared is 9. So that would be 9 pi. So let's simplify that a bit. 9 pi over 5 is equal to theta times by 9 pi over 360. And I've just simplified that because that would just be 1. So I can bring the numerators together. What can I now do? Well, I can multiply it by 360. So 360 times by 9. So 360 times by 9. 9 times 0 is 0. 9 times 6 is 54. And 9 times 3 is 27. Add the 5 is 32. So that would give me 3,240 pi over 5 equals theta times by 9 pi. There are loads of ways that you can continue this. You just do whichever method works best for you. I could first of all simplify 3,250 divided by 5. So let's start there. So 3,240 divided by 5. 5's into 3 don't go. 5's into 30 is 6, remainder 2. 5's into 20 is 4, remainder 4. And 5's into 40 is 8. So let's rub that working out from, oh, something strange has happened. Where's my slide gone? So my slide just strangely disappeared there, but let's continue. So 3,240 divided by 5. 5's into 32 go, I already did this, didn't I? Okay, anyway, 5's into 32 go 6, remainder 2. 5's into 20 go 4, remainder 4, and 5's into 40 go 8. So I'm left with 648 pi equals theta times by 9 pi. So what could I do to find out theta? I can divide both sides by 9 pi. So that would get me 648 pi divided by 9 pi equals theta. Pi divided by pi cancels out, and then I'm just left with 648 divided by 9. 9's into 6 don't go. 9's into 64 go 7, remainder 1. And 9's into 18 go twice. So therefore theta is 72 degrees. Remember, theta is just another, it's a mathematical symbol for an angle. So theta is 72 degrees, or you could say angle XYZ equals 72 degrees. Okay, for the next part, I haven't actually read this yet. Let's see. So the ratio py to xy is 2 to 3. Okay, so I know that xy is 3. So py is going to have to be 2. That's quite a nice ratio. Okay, so I know that the length over here is 2 centimeters. And I need to calculate the size of the shaded area. Okay, so what am I going to need to do there? I'm going to need to use the area of a sector formula. So what was that again? It was theta over 360 times by pi r squared. Now I know that my angle I've worked out is 72 degrees. So let's just see if we could simplify that. 72 over 360 is the same as 36 over 180 if you just divide by 2, which is the same as 18 over 90, which is the same as 9 over 45, which if I divide by 9 is 1 over 5. Okay, so I can just make life easier by simplifying that fraction. You don't have to. So I know that so the area of the sector is going to be 1/5 times by pi r squared. And now I just need to work out what the radius is. So the shaded area is going to be the area of this whole sector minus the area of this little sector here. They both have the same angle, so I can multiply both of them by 1/5. So area of big sector is going to be 1/5 times by pi r squared. If the fifth thing is confusing you, just use 72 over 360. I just did it to simplify the numbers. 1/5 times by pi r squared. Well, this long radius here is 3, so that would be 1/5 times by 9 pi. So that would be 9 pi over 5. And the area of the small sector is going to be 1/5 times by the radius was 2. So 2 squared is 4, so that would be 4 pi over 5. And how do I work out the shaded area? I do the big area, take away the smaller one. So I'm going to do 9 pi over 5, take away 4 pi over 5. Whenever you add or subtract fractions, they need to have the same denominator, so I'm super lucky that these do. And that would just give me 5 pi over 5. And actually, if I simplified that, that would just leave me with pi. And I could write pi centimeters squared. Okay, so in this question, I'm told that Kieran has 13 workers he can use for a job. He knows that 6 workers would take 14.5 days to complete this job. Show that Kieran has enough workers to finish his job in less than 7 days. So I know that 6 workers take 14.5 days. This would mean that 1 worker would take, now this is inverse proportion because obviously the more workers you have, the quicker the job will get completed. So 6 workers, I would divide by 6, and because it's inverse proportion, I would do the inverse. So I would times this by 6. So 14.5 times by 6 gives me 87 days. So 1 worker would take 87 days to complete this job. Now he has 13 workers. So how do I get from 1 to 13? I times by 13. Therefore, I'm going to have to divide by 13. So 87 divided by 13 is 6.692. 6.692 days. And 6.692 is less than 7 days. So he has enough workers to finish this job by 7 days. This is a nice simultaneous equations question because it's actually put into context so you can see like how simultaneous equations work in real life. Now they haven't written it to you in terms of algebra, so it's up to us to do that. So 3 teas and 2 coffees have a total cost of £7.80. So I can just use T as the algebra for a tea and C for a coffee and that must equal £7.80. So all I've done is I've turned these words into an algebraic expression, into an algebraic equation. T represents the teas and C represents the coffees. And then I do the same with the next one. 5 teas and 4 coffees have a total cost of £14.20. Okay, so this happens in real life. Sometimes you pay for something and then you don't actually know what the individual things cost, but with simultaneous equations, we can actually work that out. So the first thing you want to do when you've got simultaneous equations is you want to pick one of the variables, either the t's in this case or the c's, and you want to make sure that they are the same. So the easiest thing to do in this case would be to manipulate the c's. Now, I want to get them so that they're both exactly the same. So I want to make it so that as though there's 4 coffees. So what can I do? I can multiply this whole equation by 2, because then that would turn 2c into 4c, and then the variables would be exactly the same. So step 1 is you want to make sure you have one variable that is the same. Okay, so if I multiplied this by 2, that would give me 6t plus 4c equals £15.60. Okay, so this is this equation just multiplied by 2. We have to multiply each little individual part by 2. And then I'd write out the next equation underneath. And now, because I have something that has the same variable, so if I just imagined it, so 6t over here plus 4c, it gives me £15.60. And if I did the same here, 5t, oh, let's do it pink, 5t plus 4c equals £14.20. If I subtracted these equations, so I'm like, okay, what do I have in common? Because if whatever I have in common I can eliminate, I get rid of these, but I always have to subtract everything else. So I get rid of 5 of these, so I'm just left with one little coffee here, and then whatever £15.60 take £14.20 is. So whenever you've got simultaneous equations, you're trying to find the same variable, and then you decide whether you add or you subtract the equations. So in order to eliminate the variable, in order to get rid of these 4 coffees, what am I going to have to do? I'm going to have to subtract. So you put a subtraction sign here, and then 6t take away 5t just leaves you with t. 4c take 4c cancels, that's why I'm doing this. And £15.60 take away £14.20 would give me 40 pence, £1.40. Okay, so you figured out that the value of one of the t's is £1.40. Now, once you know the value of one of your variables, what you can do is substitute it back. Okay, so substitute it back into one of the equations. And it's always better to just do the smallest one because it's just less work. So I now substitute it back into the equation. So if t is £1.40, £1.40 times by 3 is going to give me 0 times 3 is 0, 3 times 4 is 12, 3 times 1 is 3, plus 1 is 4. So that would be £4.20. So £4.20 plus 2c must equal £7.80. So 2c is going to be £7.80. Take £4.20, which is £3.60. And if 2 coffees are worth £3.60, I'm just going to divide both sides by 2. So a coffee is going to be £1.80. Okay, so you know the price of your tea is £1.40 and the price of your coffee is £1.80. So just as a recap, with simultaneous equations, find a common variable. If they're not common, then you need to manipulate times the equation by something. Line them up, decide whether you have to add or subtract them in order to eliminate that variable. Step 3, subtract them or add them and find out one variable, so in this case the t's, and then you substitute the value of that into the equation in order to get your next variable. We're told that Martin used his calculator to work out the value of the number p. He wrote down the first 2 digits of the answer on his calculator. Now, this is really important. It doesn't say that he did any rounding. He just looked at his calculator and he wrote down the first 2 digits. So he wrote down 1.2. And we need to complete an error interval for p, which means we need to figure out the minimum possible value that it could have been and the maximum possible value that it could have been. Now, if we look at the error interval, it's given in the form something is less than or equal to p, which is less than the greatest value. So this, it could be something larger than the value that we see in the calculator. But let's have a think. If on the calculator you saw the digits 1.2, the smallest possible values that could come after it would be 0.0000000. That's the smallest value that it could be. So 1.2 would be the minimum value. And if we think about the maximum value, well, what's the largest digit that could come next to the 2? It could be 9, then 999999999. So that would be the technical 1.29 recurring would be the technical maximum value. But because with the error interval, they have not given us is less than or equal to, they've just said it has to be less than, we would write 1.3. However, if that's confusing and you wrote 1.29, you would still get the marks. This is technically the correct thing. That is the largest value it would be. It's just because the error interval is written in the way such that it has to be less than the maximum value. And just a quick note, what this is called is truncation. And truncation is where you literally just chop off the digits. You ignore everything else. You don't do any rounding. You just truncate. So it's different to normal where they've given you a rounded value and then you have to like find that midway point. You need to just look at it and think, okay, they've chopped it off. They've disregarded anything else. I just know that the first 2 digits are 1.2. So it's the minimum possible value and the max. So in this question, I am told that at the beginning of 2009, Mr. Veal bought a company and the value of the company was £50,000. Each year, the value of the company increased by 2%. So whenever I'm dealing with compound interest, it's helpful to think my original value is always 100% and it's increasing by 2% each year. So in total, that's 102%. What does percentage mean? It means over 100. And 102 over 100 is 1.02. So my multiplier is going to be 1.02. And I'm asked to calculate the value of the company at the beginning of 2017. So from the beginning of 2009 to the beginning of 2017, that's a difference of 8 years. So using my compound interest formula, I'm going to do the original value times by my multiplier to the power of n, which represents the number of years. So my multiplier, I know it's increasing by 2% each year. So as a multiplier, that would be 1.02. The reason we have to include the 1 is because we're still including the value. We're working out 2% of the already existing 100%. And I'm going to do it to the power of 8. If you needed to, you could just go 2009, 2010, 11, 12, 13, 14, 15, 16, 17. It's fine if you need to count in fingers just for things like this. So if I just type that into my calculator, 50,000 times by 1.02 to the power of 8 gives me £58,582.96905. Now the question says give your answer correct to the nearest 100. So I'm going to look at my hundreds column, look at the number next door. It's more than 5, so I add 1 more. So that would become 58,600. So another compound interest question, but this time I haven't been given the multiplier and I need to work it out. So at the beginning of 2009, the value of a different company was £250,000, and in 6 years, the value had increased to £325,000. This is equivalent to an increase of X% each year, and I need to work out what the value of X is. So my starting value is £250,000. It's being multiplied by my multiplier. And once it's done that, and my multiplier is being done to the power of 6 because it's 6 years, it equals £325,000. So I could just start by rearranging this formula, and for now I'm going to call the total multiplier x. Okay, so that's including the original 100%, but just for ease of working. So the first thing I could do is divide both sides by £250,000. I'm just rearranging. Whenever you've got algebra involved, to solve it, you just want to rearrange, move things from one side to the other until you're just left with your variable. So x to the power of 6 is going to be 325,000 divided by 250,000, which gives me 13 over 10, which is 1.3. So I know that x to the power of 6 is 1.3. So what I then do, oh, I don't know why I put a 3. I then root 6 both sides. So I'm doing the inverse. Instead of being to the power of 6, I'm finding the sixth root. There isn't like a proper mathematical term for it. So x is going to be, and to do that in your calculator, you see that button where the square root is? Above it in the purple, or in whatever your calculator is, will be an equivalent. So you can have a little space at the top to enter the 6 in, and then you enter 1.3. And that tells me that x is 1.044697,508. Now remember, this is a multiplier, so it includes 100% plus my x value, the interest rate. So what I want to do is take away 1, because that would just leave me with the additional multiplier. So if I take 1, I am left with 0.044697,50792, and I'm asked to give my answer correct 2 significant figures. So I look at the second significant figure, look next door, it's more than 5, so I'm going to add 1 more. So that would be 0.045. Be really careful you don't get caught out by here. 1.045, if I'd rounded it, that includes your original 100%. So the actual increase is just 4.5%. And obviously, also, you're going to want to write that as an actual percentage. I round it, once we've turned it into knowing what my multiplier is, if I times that by 100, that turns it into a percentage. So that would give me 4.5%. Okay, so in total, that would be 104.5% as the multiplier. Question, I've been given a cumulative frequency graph with its corresponding table of values. Jen draws this cumulative frequency graph for the information on the table, and I need to write down 2 different things that are wrong with this graph. So let's start by looking at the axes. I know that the y-axis, even though she hasn't labelled it, is the cumulative frequency, but I don't know what the x-axis represents. So the first thing that I would say is that she hasn't labelled the x-axis. You could also call it the horizontal axis, but she hasn't told us what that represents. It should have been time. Okay, next let's have a look. So whenever you plot a cumulative frequency graph, you always plot it against the x value and the cumulative frequency. So your x value is always going to be the upper end of the class interval. So let's see if she's done that. So the first coordinate should have been 10, 4. Has she done that? So 10, 4 would be over here. No, she hasn't. What has she done? She has plotted against the midpoint instead of the upper class interval, or the top end. Okay, so instead of the top end of the interval. You always, when you're doing a cumulative frequency graph, always use the highest value as your x. Okay, so in this question, I'm told that a factory makes 450 pies every day, and that they're either going to be chicken or steak pies. And each day, Milo takes a sample of 15 pies to check, and the proportion of the pies in his sample that are chicken is the same as the proportion of the pies that made that day that are chicken. So on Monday, Milo calculated that he needed exactly 4 chicken pies in his sample. So out of his whole sample, which is 15, 4 of them were chicken pies. And that is the same proportion as the total amount of chicken pies made. So I can set up an equivalent fraction. I know that 4 out of my 15 from my sample must be equivalent to something over 450. So then what I need to do is figure out, how did I get from 15 to 450? Well, what I can do the reverse. So I can just do 450 divided by 15 to figure out what I would need to multiply by. So 450 divided by 15, I know that 5 is going to be a common multiple, so a common factor. So 15 divided by 5 is 3, and 450 divided by 5, if I didn't know that, then once again, just to use the bus stop method. So 5s into 4 don't go, 5s into 45 are 90, are 9, and 5s into 0 is 0. So that would give me 90 over 3, which is 30. So then you know that the equivalent fraction, if you times this by, jumped ahead there. So that means that 450 divided by 15 is 30. So this divided by 30 would get you back to this fraction. So to times by 30, you get from 4, times it by 30, you get 120. Okay, so we did this division to figure out what we needed to divide by to get to this way, and then you can do the opposite to get to the other fraction. So 120 chicken pies. Okay, so in this question, it is a show that question, which means you want to show all of your working out and a logical chain of reasoning. Now, we are told that a right angle triangle is formed by the diameters of 3 semicircular regions, A, B, and C, as shown in the diagram. So we need to think about what information we know. Now, any right angled triangle, I automatically know I can use Pythagoras or I can use trigonometry. So that should automatically come to your minds when you see a right angled triangle. And I'm dealing with circles, so it's helpful probably to just write down the area of a circle. Area of a circle is pi r squared. I need to show that the area of region A is equal to the area of region B plus the area of region C. So what I'm going to do is start by just writing out Pythagoras' theorem, which is a squared plus b squared equals c squared. Now they've labelled this diagram already, so I'm going to go with their diagram. So this is the region of A, so I'm going to label that side little a, this side little b, and this side little c. Normally Pythagoras is the two smaller sides at A and B. In this case, the largest side is going to be A, but that's fine. So what I need to do is work out an expression now for each of my regions. Now I know the area of a circle is pi times radius squared. I know that the diameter of each of these, so I could have used anything. I could have used X, Y, Z, but I'm just going to use A, B, and C because I'm just forming an expression. So the diameter of big A region is A. Now it's a semicircle, so the area of a full circle is pi r squared, but because it's a semicircle, it's going to be pi r squared divided by 2 because it's half of a circle. So how could I form an expression for the radius? Well, I know that the radius is half of the diameter. So if the diameter is A, because I'm just labeling this side A, then the radius is going to be A over 2. So let's substitute that into my equation. So the area of a circle is pi times, and let's change this actually, so pi r squared times by a half. It's the same as dividing by 2. So pi times a over 2 squared times by a half. So that's the area of A, which is pi times a squared over 4 times by a half, which is pi a squared over 8. So that's the area of A, so pi a squared over 8. Now, if I did the same thing for the region of B and C, I would get pi b squared over 8 and pi c squared over 8. I could go through it, but I'm running out of space. All I'm doing is, instead of A, I'm using B, because the diameter for this one is B and the diameter for this one would be C. Again, you could have used X, Y, or Z or anything. So I've got this expression. Now, to show that expression, and obviously my slide is like a landscape, yours is going to be portrait. You're going to have a lot more space, and the ideal is to always work vertically, but I'm dotted around the place because it's a little bit of a strange setup. So what I need to do is show that this then simplifies to Pythagoras. So what can I do? Well, I can multiply the equation by 8. So multiply each part of the equation by 8. So I'm left with pi a squared equals pi b squared plus pi c squared. And then what can I do? I can divide by pi. So divide everything by pi. So I'm left with a squared equals b squared plus c squared. And that is Pythagoras' theorem. So I'm showing that the area of region A must be equal to the area of region B plus the area of region C. So show that questions are literally use the knowledge that you have, go through it meticulously to just prove something or show it. State pi's Milo needs in his sample is 6, correct to the nearest whole number. And he takes at random a pie from the 450 made on Tuesday, and I need to work out the lower bound of the probability that the pie is a steak pie. So let's just think about our sample size again. I know that there are 15 pies in the sample, and his sample is 6, correct to the nearest whole number. So what are the whole numbers surrounding 6? 5 and 7, and I want to work out the lower bound. So the lowest possible thing it could have been before it rounded up to 6. That would be 5.5, because if it was 5.49 recurring, that would round down to 5 pies. So the lowest possible amount of pies that could be in his sample is 5.5. I need to then turn this into something out of 450, and from the previous question, I already know that if I times 15 by 30, I get to 450. So I'm going to have to do 5.5 times by 30. How could I do that with a non-calculator? I could break that up into this. So 5.5 times by 10 is 55. And then 55 times by 3 is going to be 165. So you know that it's 165 pies, but it says write it as a probability. So make sure you always read the question carefully. So that would be 165 over 450. Okay, so here I'm being asked to factorize fully. Okay, now when I'm factorizing, what I'm doing is I'm putting things into brackets, but what you're trying to do is you're trying to extract or squeeze as much as you can and put it outside the bracket. So as much as possible is outside of the bracket. So a common thing that people would do with a question like this is they think, oh, this is the difference of 2 squares. So therefore I could just factorize it as 2p plus 6, 2p minus 6. And yes, you could, but that's not factorizing it fully. So we just need to be really careful if we've got something that is not quite so simple. So if it was p squared minus 36, yeah, it would just be p plus 6, p minus 6, but we've got a coefficient to p squared. So the first thing we want to do is factorize that out. So if I factorize that out, I'd be left with 4p squared minus, and 36 divided by 4 is 9. Okay, so I've factorized that so that I still have my difference of 2 squares over here, but I've factorized out as much as I can to begin with. So then I can factorise the difference of two squares. So it'd be p plus 3, p minus 3. Okay, so this is a lot more factorised than saying 2p plus 6, 2p minus 6, because when you're factorising, you want to extract as much as you can and put it out of the bracket. Okay, so that is the best way to do this. When you're factorising fully and there's a coefficient in front of it, you can do it this way. So factorised fully would be 4p plus 3, p minus 3. And the difference of two squares, if you've forgotten, then just make sure you look it up. But really briefly, it just means that if you've got x squared, take away y squared, then when you factorise it, it would be x plus y, x minus y. Really tricky question. Whenever you're dealing with ratios, equivalent ratios, always bear in mind this one thing. So let's just look at an equivalent ratio. So I know that 2 to 3 is the same as 4 to 6 because all I've done is I've doubled that. Okay, so I know that they're equivalent ratios. Now, how could I express this? Well, I know for a fact that 2 over 3 is also equivalent to 4 over 6. So when you're dealing with equivalent ratios, what you can do is turn them into fractions because then you're able to manipulate them. So you might just want to think back to this example. Whenever you're stuck, just always try and think it back to a numerical example and see how it can make sense. Okay, so I know that a ratio divided by another ratio is equivalent. It's going to be in the same proportion as the other equivalent ratio over the ratio. So let's see what that means. It means that I can write y plus x over y minus x must be equal to k over 1 because I'm following the same rules as I did here. Now that I've got fractions, I can try and manipulate them to solve them. So I know that anything divided by 1 is just 1. So that would just leave me with this. And then what do I want to do whenever I've got a denominator with algebra? I just want to multiply it by that denominator to get rid of it. So if I times both sides by y minus x, I'd be left with y plus x equals k, y minus x. And then what I need to do, I'm being asked to show that y equals something. So I just need to rearrange everything to make y the subject. So let's expand the brackets. Y plus x is going to be ky minus kx. And if I want to make y the subject, I know that I need to bring together all of the y terms. So let's think about what it's wanting me to do, because there's a few ways we can do this. I know that x, if I factorised it, I want to get it to the form k plus 1. So therefore, let's move the x's first. Let's add kx to the other side. So y plus x plus kx equals ky. So now I can move the y. So x plus kx equals ky minus y. And then we can do some factorising. So whenever you've got an equation where you've got x variables and y variables and you've got more of one of each, just split them up so that all the x variables are on one side and all the y variables are on the other side. Then you can factorise. So let's factorise this. So if I take x out of the equation, I'd be left with k plus 1, or in this case it would have been 1 plus k, but I know that this is the form they want it in. And then over here, if I take y out of the equation, I'd be left with k minus 1. And what's the next part? Well, I want to get y on its own, so I'm going to divide both sides by k minus 1. So x k plus 1 over k minus 1 equals y, which is what I have been asked. Okay, so here I've just got a calculation that's been multiplied to the power of 4. Now, if you're not 100% and you sometimes forget your index laws, the best thing to do is to think about what is the algebra actually doing. What does to the power of 4 mean? It means multiplied by itself 4 times. So what I could do is actually write this out. So let's just split it up, because whenever we're dealing with algebra, there's always a little invisible multiplication sign between each term or each part of the term. So I know I've got that times by 3 times x to the power 5 times by y to the power 6 times by 3 times x to the power 5 times y to the power 6, and then again times by 3 times by x to the power 5 times by y to the power 6. So when I have it laid out like this, it makes it a little bit easier to see what I need to do. Now, if you're not 100% sure on your multiplying with indices, that's probably something you want to get familiar with. Worst case scenario, what you could do is you could write everything out like this. So x to the power 5 means x multiplied by itself 5 times, and then write out y as well. But hopefully we know the law of multiplication is that when I am multiplying indices, so x to the power of 2 times by x to the power of 5, I add them. So that would become x to the power of 7, because what does x times x mean? It means x times x, and then x to the power 5 means x times x times x times x. So in total, you are multiplying x by itself 7 times. So law of multiplication is one we definitely need to know. And then what I can do is see that I am multiplying 3 by itself 4 times. Okay, so 3 times by 3 again, and times by 3 again. 3 times 3 is 9, times by 3 is 27, times by 3 is 81, but you've also got a calculator, so use that to your advantage. So I know it's going to be 81. Then let's deal with the x's. So x to the power 5 times by x to the power 5 times by x to the power 5. What do I do? Well, that becomes 5 plus 5 plus 5 plus 5 is 20. And the law of brackets, so if you want the shortcut way, the law of brackets is that each of these things are going to be done to the power of 4. So 5 times 4 is 20, and 6 times 4 is 24. So the law of brackets, I'll just write it up here. The law of brackets is that you multiply the indices together when they're in a bracket. Okay, so you multiply the powers. But sometimes people get confused by this, and also sometimes they forget to multiply just the number by itself, so they forget that 3 needs to be to the power of 4 as well, which is why it's helpful to just write out what's happening with the algebra. But anyway, let's finish this off. So we've got y to the power of 6 times y to the 6, y to the 6. So 6 plus 6 plus 6 plus 6 is 24. Okay, so I've done a few ways that you can do this. Obviously, the quickest way is the law of brackets, but just remember, be mindful that you're also... Okay, so in this question, I'm told that Faiza is studying the population of rabbits in a park. She wants to estimate the number of rabbits in the park. So this is an estimating population kind of question, which is also known as capture recapture. Now, on Monday, she catches a random sample of 20 rabbits in the park, marks each rabbit with a tag, and then releases them back into the park. So I know that she catches 20 rabbits out of the total population. So N can represent the total population. Okay. On Tuesday, she catches a random sample of 42 rabbits in the park, and 12 of the rabbits are marked with a tag. So 12 out of 42 rabbits are marked with a tag. Now, when we do questions like this, the idea is that if you grab if you grab a certain amount of the population, let's say 20, you tag them, you then release them, they're going to disperse amongst each other, and then you capture another bunch, and then however many of them have tags is going to be proportional to the amount in the whole population. So what we do is we make the fractions that we've created equivalent, and then what we want to do is just solve them, rearrange them in order to get an estimate for the total population. So 20 over n is equivalent to 12 over 42. This is a calculator question, so I could just say 20 over n equals 12 divided by 42, which is well, let's just leave it as 2/7 because I don't want to write all of that out. But if it was a decimal, it would make this a little bit easier to show. What I can do, because n is my denominator, I can multiply both sides of the equation by n. So I'd be left with 20 equals 2/7 times by n. So I've got n as on this side and it's no longer a denominator. What can I do next? Well, n is being multiplied by 2/7, or I could have left it as 12/42. I just simplified it. So then I'm going to want to divide by 2/7 because I always do the inverse to move anything from one side of the equation to the other. So 20 divided by 2/7 is 70. So therefore, n must be 70. So we can let Faisal know that there are roughly 70 rabbits in the park. Okay, so another reasoning question. I'm told that Albie is studying the population of rabbits in a wood. One day he catches 55 rabbits and finds that 40 of these rabbits are marked with a tag. Albie estimates that there are 50 rabbits in the wood. Explain why Albie's estimate cannot be correct. Well, he's caught 55 rabbits. So if there are already 55 rabbits present, how can there only be 50 rabbits in the woods? So your sample size, a way to explain this would be that your sample size, so the amount of rabbits that you catch, can't be greater than the total population. Because does it make sense that there are more you catch more rabbits than actually exist? No. Okay, so here we've got a few rearranging formula because it can come up in so many different ways. So rearrange to make x the subject. The first thing you want to do, if something is affecting every part of one side of the equation, then that is what you want to get rid of. So the whole of this fraction is being cube rooted. So the first step is to cube both sides. So y cubed would be equal to x to the power 4 plus 3 over 7. Then we've got it into a nice little fraction and we can just do what we'd normally do. Because x is stuck up here, we can't do anything, we can't move anything up here. If something's in a fraction, you have to first eliminate the denominator before you can touch anything on the numerator. So everything is being divided by 7, so we times both sides by 7. So that would be 7y cubed equals x to the power 4 plus 3. Then what do? We take 3. So that would be 7y cubed take 3 equals x to the power 4. And then the final part is you're going to want to do the root 4 7y cubed take 3 is going to give you x. So you're always, just to move anything from one side of the equation to the other, you just do the inverse. Over here we've got another subject of the formula. So you've got two terms that have x in it. So what you want to do, if you've got two terms that have x in it, bring them both to the same side, and then you're going to want to factorize. So let's move everything around. So you've got 8x minus pi x. I'm going to take pi x from both sides. And at the same time, I'm then going to add 7 just to make it a little bit quicker. So that would equal 4y plus 7. You could have done it in 2 steps if you prefer. So now I've got both of my x terms on one side. What I can do is factorize it so that I just get x on its own. And then if I factorize that, I just have one lot of x and I can divide both sides by whatever's in my bracket. So if you divide both sides by 8 take pi, you're left with x equals 4y plus 7 over 8 take away pi. And there you've rearranged it. Okay, so another rearranging. So I've got x as my denominator. So the first thing I want to do is multiply both sides by x to get rid of that as a denominator. The next thing I can do is expand my brackets. So yx equals 8a minus 16x. And remember that when you've got two terms that contain the thing you want to make the subject, you want to put them on the same side because then you can factorize them. So I'm going to bring over 16x equals 8a. And then I've got two terms with x in it, so I can factorize the x out. So that would be xy plus 16 equals 8a. And therefore, the final step would be to just divide both sides by the bracket. So 8a is y plus 16. So let's try that with a slightly harder one. Same principle though. So times both sides by the denominator, because that's what you want to do so that you don't have a fraction. So y multiplied by x minus 2 equals 4x plus 3. We're going to have to expand this because x is the term that we want. So yx minus 2y equals 4x plus 3. Remember that you're going to want both of your x's on one side. And I'm going to move the y over here because otherwise everything's going to be negative. Remember, you can play around with things, moving them from one side to the other as much as you want. It doesn't matter as long as you're doing the inverse operation. So yx equals 4x plus 3 plus 2y. Then if I subtract 4x, I'm left with yx minus 4x equals 2y plus 3. Now I can get to the point of factorising. So x is going to be y take 4. So all I've done is I've factorised x out of it. So that is over here. And then the final step, just divide by the bracket. So the key thing here is everyone seems to find these things a little bit tricky, but all you want to do is when you've got a complicated thing like this is jiggle things around, move things from one side to the other. Eventually you're going to get two terms that have x or y or whatever it is that you want to make the subject. You just bring them together on the same side, factorize it, and then divide both sides by the... Okay, in this question I am told that P, Q, R and S are 4 points on a circle, and that I have P, X, R and S, X, Q are straight lines. So these two lines here are straight. Prove that triangle PQX and SRX are similar. Okay, so in order to prove similarity, I have three options. The conditions of similarity are that all three angles are equal, all three corresponding angles are equal, and this is generally proved by just proving that two angles are equal, because if two angles are equal, the third must be equal because angles in a triangle sum to 180. Or a side, an angle, and a corresponding side are equal. So the side, the angle, and the side, and the same corresponding set in the other triangle, or by all three sides are equal. So, I mean, I'm going to have a guess and say that the best option from this is going to be proving our angles, but let's have a look. So I was told that these two lines here are straight lines. If they are straight lines, then you have over here vertically opposite angles. So if you've forgotten about this, then vertically opposite angles are equal. And they are formed by two straight lines crossing. So they look like a cross like this, and we know that they are equal. So therefore I know that angle QXP must equal angle RXS as vertically opposite angles are equal. So usually, well, you're proving it. So if you're going to prove something, you must state your reasons. You have to. If you don't state your reasons, I'll be like, well, okay, how do you know? So I know that this angle is equal to this one because vertically opposite angles are equal. That's just a basic angle fact. So hopefully, even if you're not 100% on your circle theorems, you recognize that. Then what I can do is I'm going to look, I know that I've got two angles that are at the circumference. Okay, so over here, this circle theorem is angles at the circumference subtended by the same arc are equal. This is also sometimes known as the angles in the same segment. I prefer the first because it just makes more sense, because you can visually see where the arc is formed, but you use whichever one you're more familiar with, especially if you recognise it as a segment rule. So just a quick reminder, subtended just means created or formed. Okay, so it's saying angles at the circumference that are formed by the same arc are equal. And how do you demonstrate that? Well, let's use a different colour. So over here, I've got an angle here, this angle. So I've got angle PQX, okay? And let's have a look at what arc creates this. So follow the lines along and you shade the arc in. So this angle here, if I extended it, keep on extending, it's formed by this arc here, okay? So I know that that is formed by that arc, and then I can do the same for the next angle here at the circumference. This angle here, if I followed it along, what arc is it formed by? Well, it's formed by the same arc, this arc here, okay? So therefore, that circle theorem proves that those two angles are equal. So angle PQX must equal angle PR. Oh, and I've lost what this letter is. I think it's S. Is it S? Let's just check. Yeah, S. Oh, still PRS as angles at the circumference, and I'm not going to write out the circle theorem again because I wrote it out here, but this one here, okay? So as angles at the circumference subtended or created by the same arc are equal. The next thing I need to do is prove my next angles are equal. So let's have a look over here, what's going on. It looks like I've got angles at the circumference again. So let's just double check if this is true. Well, if I extend the arc, if I extend the angle, it's formed by this arc here. If I do the same to this angle, once again, it's created by this arc here. So I could say angle QPX must equal angle QSR as angles at the circumference subtended by the same arc are equal, and that's absolutely fine. Or you could say must equal angle QSR as angles in a triangle sum to 180 degrees. And obviously if you've got two angles that are equal, you have the same amount that is going to be left over for the missing angle. So you can choose whichever works best for you. And if you've proven that three angles are equal, so the last step, you'd say AAA, all three angles in both triangles are equal, therefore the triangles are similar.